Thanks, Lydia. Thanks for the introduction. It's been some time since I did some of that work you mentioned uh, in the introduction. I guess my bio probably needs to be updated to be a bit more recent. It's probably good when I joined ACENET 5 years ago, but yeah, a little outdated now. Anyway, yeah, so I've been working a lot in cloud just because there's been a fairly large need for cloud, and there's a lot of support that can be given there. So today I'm going to give a little bit of a talk on some of my experiences with that support, and I'm going to focus on sort of what you can do with the cloud in humanities and social sciences and what people are doing there. Let's see, I got to make sure the right window's clicked. There we go. All right, so what am I going to be, let's give a little more detail about what I'm going to be talking about. So at a high level, I want to give people an idea of what the cloud is. The word cloud is kind of a bit of a buzzword. It can mean lots of different things. And I want to talk a little bit about what those different things that can mean are, and what it means specifically with the Compute Canada cloud. I also want to give you a bit of an idea of what a workflow specifically with like our type of cloud looks like. There's lots of variations in that, but I want to give you a rough idea of what's sort of involved with working with the cloud. I want to give some examples and talk about some different ways that the cloud can be used for humanities and social sciences projects. I want to talk about, and one of the most common things that people like to do with the cloud is to run websites. And there's a couple different types of websites that you can run. Dynamic websites are quite popular. They've been used a lot. And then there's also static websites. Those are the sort of main two categories. And I want to talk about what the differences are, why you might want to use one versus the other. And I want to mention some important points to consider when you're planning a website. Some of the maintenance and security things you might want to be thinking about before you decide to take one route or another. Okay, so what is a cloud? That's the sort of the first thing I want to clear up and have people sort of on the same page about. So the word cloud, as I said, can mean a lot of different things. It could be Gmail, for example, could be thought of as a cloud service or cloud software that you use available through the internet. For example, like Gmail calendars and those kinds of things. Then you can sort of take another step back and look at cloud hosting, which is, for example, if you wanted to set up a website, you could use services for cloud hosting, which provide a platform in which you can create your websites and present them to the world. And then you can sort of take another step down. We're going to go over this again to get a bit on the next slide, but you can go a step down from that and look at it sort of as an infrastructure. And what I mean by that is sort of computers. So you can use cloud at the level of which you'd use your desktop computer. You can choose what operating system you have on it and those kinds of things. So those are kind of the different meanings that people often associate with the word cloud. We're going to dive into that a little more in the next slide. But what is the cloud? Well, physically, it's a bunch of computers. So I've got this picture on the right. This is actually our Cedar cluster, which has a cloud component. I don't know if those particular computers that are in that box on the right there are the cloud computers or not, but they look very similar. I've been into the Arbutus data center, which is our main cloud, the main Compute cloud in Victoria, and their systems look very similar. There were these kinds of racks with lots of boxes connected with network cables. So it's a very compact way of storing lots of computers, basically. These computers don't have monitors and things attached to them like we normally have, but that's what they look like, these big racks full of computers. So that's kind of what they look like, and you work with them sort of from a remote location, which does have a monitor, like from your desktop or laptop or whatever. And so you can use these remote apps, remotely, like Gmail and stuff, if the cloud is offering those kinds of services, or you can use remote connection tools to work at it at a lower level, for example, at the infrastructure level. Okay, sorry, I lied. The next slide is actually about virtual machines. Okay, so I talked about the cloud being a bunch of computers. So the physical computers in those racks. And those computers, you can uh, basically divide them up in different ways. So for example, if you want to give someone access to one of the computers in that rack, you don't necessarily have to give them access to the whole computer. A lot of modern computers have many cores in them. Say, for example, my laptop, I think has at least 2, probably more like 4 cores. Many people's laptops do. These cloud computers have many cores, more like 24, 48 kind of numbers of cores that actually do these calculations for you and run your software. And so you can divide these things up in various ways. And a virtual machine is a way of dividing up those resources. You can kind of think of a virtual machine as a simulated computer, if that it has meaning for you. But basically what it is it's some software, a program that runs on these physical machines that allows you to give out bits of the physical machine to run these simulated computers to various researchers, the different projects and things like that. So for example, on the right, I've got a little diagram of how you might break up one of these physical machines. So the whole block, I wanted to represent one computer that's sitting in our data center. This computer is actually kind of a small one, more like a laptop. It has 4 cores. So here I've got the different CPUs listed, shown. And then I color coded them with different shades of gray for different virtual machines. So virtual machine 0, for example, has 1 CPU. RAM is the memory that it has access to for storing variables in the computer's memory. And so it has a little bit of that memory and a little bit of that of the disk on that, the hard drive on that physical computer. And similarly for VM1 and VM2, they get their own little portions of that computer that they can work with. And so you can run, so for example, the virtual machine that you have access to can have a different physical profile or a different physical, different virtual, I guess, components than the actual underlying computer that's running it. So you could have 3 or 4 computers or more running on one physical computer and divide up the resources based on the specifications that the user chooses. So how many CPUs they want, how much RAM, and that kind of stuff. So that's a little bit about what a virtual machine is. It's a way of dividing up these physical machines into different bits that you want to work with, and sort of specifying how much resources you need for your particular task. The other thing that you can do with virtual machines is, for example, the computer that's running these virtual machines, the physical machine, it can have one type of operating system like Linux or Windows or Mac OS X. They're usually Linux. But then you can run another machine on top, a virtual machine on that machine that has a different operating system. So for example, you could run a Windows machine on a Linux operating system. So that can be useful to be able to allow people to choose whatever operating system they want to run on their virtual machine. You can even run virtual machines on your laptop. There's a tool called VirtualBox, which has been around for some time, that allows you to run these virtual machines on your laptop. And this is actually where I first encountered the term virtual machine, was when I was able to started playing around VirtualBox and making these virtual machines on my laptop, which is kind of neat. You can test out things on your laptop. Like for example, I usually use Windows on my laptops, and so I could run a Linux machine if I wanted to on my laptop and play around with Linux software. So that's what a virtual machine is, and that's and it kind of fits in very nicely with these cloud frameworks, where you have a bunch of computers that you want to allow people to use, but want to allow them to have lots of flexibility. You can allow them to create these virtual machines inside it and divide up the resources as they need. So I said I was going to get back to the sort of levels of which you can use a cloud platform. So for example, here I've got a bunch of different levels specified. At the top level, you've got the application level or the software as a service level, where you have things like Google Drive, Gmail, WordPress, etc., where the software is already installed and set up. They take care of the operating systems, like the Linux or Windows operating systems that run these bits of software, and you don't even have to ever see that or worry about it. You just go in and use your Gmail or your WordPress, you log in and edit pages and whatnot. And so at that level, it's very easy to use. You don't have to worry about all the things you'd have to worry about in terms of taking care of an operating system and things like that. But what that does mean is you don't have any choice in the matter in terms of what operating systems are used or how things are configured. So you lose a lot of the flexibility and configurability that you might get otherwise. And as we move down these different levels, you've got platform as a service, which is maybe more like, for example, our high performance computing clusters. I didn't mention too much about them, but they're another set of computing resources that you can use, which are kind of more at a platform level where you can, there's not necessarily a specific piece of software you're using directly, but you can interact and choose different pre-installed pieces of software to run. You can build your own and those kinds of things. So you have often access to different programming languages and databases and things like that you can kind of put together and use as makes sense for your project. And then underneath that, you have at a sort of a lower level with more control is what's called infrastructure as a service. So there you can work at this even at a lower level where you can actually choose how many cores your computer has, how much RAM it has, how much storage it has, or how many different drives are attached to it, things like that. So you have quite a lot of ability to choose how things are configured at this level. Now at this level, you're starting to enter a fairly large amount of work that could be involved there in terms of installing operating systems, formatting drives, and things like that. And there's even one step lower where you actually just have access to a physical computer, where you have to worry about internet connectivity and power outages and stuff like that. So this is kind of the different levels at which you can access cloud, or well, really the hardware level. That's really not cloud anymore. But for example, the three levels above that: software as a service, platform as a service, and infrastructure as a service, are different levels in which you can come in and use cloud. And this can lead to a bit of confusion because cloud can be, as you see, quite a different experience depending on which level you come in at. Yeah. Okay. So I want to put it out there that Compute Canada clouds are infrastructure as a service. So this allows the greatest amount of flexibility in terms of being able to configure your cloud usage. But it does require more effort and knowledge than platform as a service or software as a service clouds. You have to do manual setup of your VMs. You have to do maintenance, for example, like checking security logs and updating software and operating systems. And you may need to migrate between operating systems, major operating systems on your virtual machines. For example, Ubuntu 12 to Ubuntu 14 or something like that, which can be a fair bit of work because they often don't allow you to do that in place. Well, it doesn't often work if you do that in place. But this allows a great amount of flexibility. You can choose your operating system, different versions of Linux. We even have the option of choosing Windows, although that can be a bit more of a hassle for various people concerned. You can also choose the hardware configuration, as I was mentioning, different amounts of RAM and things like that. So, I mean, we would love to offer more than just infrastructure as a service. We would love to offer platform as a service or software as a service, but we really don't have the amount of personnel and funding required to do that. It's quite a lot of work to offer these higher levels of service. Not to mention that cloud is relative to, say, for example, our high performance computing clusters, which I mentioned briefly. It's a fairly new offering from Compute Canada, maybe the last 5 years or so, maybe a little bit more, compared to the high performance computing clusters, which have been offered since the beginning of Compute Canada, well, ACENET, or most of the regional partners of Compute Canada. So we're still working out some of the kinks and how best to offer it. Okay, so that's a kind of a quick overview of what a cloud is and what the Compute Canada cloud, how the Compute Canada cloud fits into the different types of clouds you can have. We have a number of different clouds, actually. So we have Arbutus, which is sort of our main cloud. It has the most hardware sitting at that site. This is in Victoria in BC. And yeah, so you can see the sort of numbers here in terms of how many nodes and how many cores it has, how much storage. So this would be what's called persistent storage, so storage that can last longer than your virtual machine's lifetime. and how much RAM you have available to the virtual machines. Now, these numbers are total numbers. So if I took all the numbers of all the nodes and added them all together, the hardware profiles of the actual physical machines, don't necessarily match. I mean, the ratios are probably similar, but there's not a machine with 146 terabytes of RAM, for example. That's the total number of all the machines added together. So we also have a cloud called East Cloud, which is in Quebec. Cedar Cloud, which is attached to the Cedar high performance computing cluster. And we have a Graham Cloud, which is part of the Graham high performance computing cluster as well. So we have a few different clouds. Usually you'll end up with the Arvidas cloud unless you have a reason for the others. What we use on our clouds, on the computing clouds, we use a cloud operating system called OpenStack. So what is a cloud operating system? It's a piece of software, like for example, you have like an operating system for your computer, like Windows or Linux. The cloud operating system is sort of something that's built on top of that allows you to control your VMs. So this would be, for example, creating VMs and deleting them, changing their storage configuration, restarting them, for example, if you need to, that sort of thing. On the right here, I've got a little picture of what the login page for our Arvidas cloud looks like. So this cloud operating system that I'm talking about, OpenStack, you actually can access through your web browser. So it gives you kind of a graphical user interface that you can click on things in your web browser to create your VMs and things like that. So one other thing, I've got a bullet point here called about billing. We don't actually bill researchers. We do track usage, but we don't charge researchers for any of their usage. It's the same as with our HPC clusters. There's no billing of these resources. There is some, if you need a large amounts of resources, there are ways that we sort of just have a process to sort of figure out who can get what kind of resources. But at a low level, everybody can, every researcher at a recognized Canadian academic institution or library can access cloud resources at some level. Okay, so what does it look like to work with OpenStack? This is another kind of screenshot of the OpenStack interface. So this is one where you would be creating a new VM. Now, I'm not going to go through all the details about how to create a VM or anything. I just wanted to give you a rough idea of what it looks like, what the interface might look like, what the interaction with OpenStack is like. And so this is just a screenshot of one part of creating a new virtual machine. So you can do things like name it and things like that. This is if you've used any other kinds of clouds, like for example, the Amazon cloud, the interface on the Compute Canada cloud is quite a bit simpler. There's much less, it gets down to the basics of what you need to do a little bit better, and I find it much nicer to work with. Because there's not as much confusing stuff going on. So you can pick, what kinds of, how you want to create your VM and different options. I'm not going to go into all of them here because that's not sort of the point of this. I just want to give you an idea of what interacting with our OpenStack cloud looks like. So it's usually clicking through GUI menus and things like that. Okay, so once you've created your VM, don't worry about the details there about how you create it, but once you've clicked through the GUI like that and created your VM, what does it actually look like to work with a VM? There's a couple different ways you can work with VMs. The way I typically work with them is through a tool called, there's a bunch of different tools that provide this, but something called Secure Shell. So this allows you to securely type commands in what's called a shell, something that will execute commands on your virtual machine for you securely. So on the top right, I've got an example of what, you can't see the text, I'm sure, but it's a little black window where I can type commands, like for example, cd or ls to change directories or list structures. knowing the details of the commands isn't important, but just wanted to illustrate what the workflow looks like generally. I'm typing commands at a command prompt to sort of do these things on my virtual machine, install software and stuff like that. And there's a few different pieces of software that you can use to do this. I use something called Putty. There's also something called MOBA Exterm. These are both Windows software. If you're on Macs or Linux, you can use something called Terminal, which is built right in to those operating systems. Now, that allows me to type commands, but I often want to edit files as well, or transfer files that I've done on my desktop, like images or things like that. And so I use something called a protocol called Secure File Transfer Protocol, which allows me to transfer files back and forth. Now, and I didn't mention this actually, but I should, the secure shell is actually encrypts all data that's sent back and forth. So nobody can look at the data that you're sending back and forth, for example, passwords or things like that, or text you're entering into files using editors on the shell. Similarly with SFTP, which the S again stands for secure, it encrypts all the data you send back and forth. It actually uses a very similar protocol to the secure shell tools. And I've got a little picture here of what it looks like to be using one of these SFTP clients, they're called. So it's a piece of software that runs on your laptop. Likewise with the shell, it's a piece of software that runs on your laptop and connects to one of your virtual machines. This is a piece of software that runs on your laptop and connects to virtual machine again. And you can edit files through here, so you can configure it. And this particular piece of software is WinSCP, which runs on Windows. You can also use MOBA Exterm. So you actually use MOBA Exterm for your shell and for your file transfer tool as well. And so you can configure it to click on files, open it up in your favorite text editor, edit them, save them, and it'll automatically transfer it back for you. And on Macs and Linux, FileZilla is a pretty good tool to use. So this is what sort of the workflow looks like generally for me. When I'm working on these VMs, I'm editing files in my file transfer client and running commands to work with those files in my shell. That's the way I like to interact with it, but you can also run graphical user interfaces like desktops. For example, you can install desktops on your virtual machine. You can use tools like VNC to connect to them remotely. If you want to run graphical programs or have a desire to work with the graphical interface in your virtual machine. It's a little more work to set those up. They don't come out of the gate that way, but you can set them up that way. Generally, it's not too bad to run over the network. Sometimes with some of the older versions of doing this, other older ways of doing this, you would require some pretty good internet connectivity, but they've gotten better in recent times. Okay, I probably spent too long on that slide. What can I do with a VM? Okay, so let's change that question a little bit. What can I do with a computer? I mean, basically a virtual machine is more or less a computer. There's some details that are a little bit different, but you can basically do the same thing with a VM that you could do with your laptop. I mean, you can't pick up your virtual machine and carry it around with you, but you can run the same kinds of programs on it. For example, you can install a graphical user interface. You can watch movies, listen to music. I mean, I'm not recommending you do this on a virtual machine. That's not really the purpose, but you could do that, for example. What people usually do with their virtual machines is they store data, they host websites and run web scrapers. The reason that they do this with a virtual machine and not, say, for example, your laptop, is that these virtual machines will have IP addresses that don't change, so you can access them quite easily. You don't move them around like your laptop, for example, so they don't become disconnected from the internet or power, so that anyone can access their websites anytime they want. So that's some of the benefits that a virtual machine would have over your laptop, for example, because you can have it on all the time, always connected to the internet, always accessible. So that's one of the reasons why people would use a VM. Why would I host a website on a virtual machine rather than my laptop? Well, that's really the main reason right there. Is it's always connected to the internet. What are researchers doing with Compute Canada Clouds? I mentioned some of the reasons why why you might want to use it, but what are they actually doing? Well, for example, some researchers will use their virtual machines to pull data down from the web. There's a few tools, for example, curl and wget, which are command line tools, tools you can use with the shell that I was talking about earlier, where you can type commands to download data from like websites and things like that, or files from the internet. And collect those, or you can build these things into scripts. There's also a tool called a library actually called Beautiful Soup, which people use quite often to read and parse websites, HTML files, and this can be used in a scripting language called Python, if you're all familiar with that. You can run these programs and scripts or even commands at scheduled times. A lot of the Linux operating systems have a tool called cron built in, which will allow you to run these commands at specific times. I already talked about SFTP a little bit, but there's other tools. For example, Globus is a tool that Compute Canada offers along with the Globus organization to allow file transfers to be quite simple. Again, it's like a web interface that you can use. So you could hook this up with your virtual machine to store files and run a Globus, what they call an endpoint. Basically, it's just a place where you can connect to and transfer files in and out. It has a bunch of options for sharing files and managing people who can share them and things like that. So you can also use HTTP, which is what the protocol that you usually use when you look at websites, right? You type HTTP, some website name in, and you'll go to that website. But you can also use it for file sharing as well. I have a group who shares a large amount of data, and they have a very basic website set up that just gives a directory listing of some specific directories on their virtual machine, and people can download files using the HTTP protocol. But by far, the main thing that people like to do is run web servers. So that's running websites on their virtual machines. So I'm going to talk a little bit more about running web servers. Okay, so what is a web server? This might not be something that the people are really familiar with. This is something that I started playing around with when I was a grad student. I was curious about. I set up my own web server in my home office. So you can do this anywhere, right? The main requirement is that you have a computer that's always on, connected to the internet with an IP that doesn't change. And so an IP is a number that looks like, maybe I mentioned IP already, but it's a internet, IP stands for Internet Protocol, I think. I could be wrong about that. But basically it's a number that allows other computers to find yours. And so I've got this little diagram here of what, for example, if I was running a web server in my office or my at home, what it might look like. I've got this computer, I've drawn it as like a desktop kind of style, just because you're not going to be probably wanting to carry it around. You want it to always be on. And it has some kind of an IP address associated with it, and it's connected to a router, Wi-Fi router or something like that, that's then connected through a modem to your internet service provider. Now, machines, it could be your desktop, you could also get a laptop, maybe a handheld device or something. You're all connected to your Wi-Fi router, getting internet access, looking at websites and stuff like that. They'll get IP addresses given to them by the router. So, and these IP addresses are just sort of allows them to be uniquely identified within the small sort of home network that you've got set up here. But you also get what's called like a public IP address from your internet service provider, and this is probably through your modem, and your router probably even knows about this address as well. And so that people out on the internet can actually refer to that IP address and get to your router. And then you can set up your router to say, oh, if there's anybody making any requests for websites coming to this IP address, let's send them to my server, right? And your server can be running some kind of piece of software. One of the common ones is Apache, which can provide them with these files, these HTML files that describe what your site looks like. And they'll download that file and look at it in their browser. Now, this all happens behind the scene. They don't have to worry about downloading files and stuff. It all just happens for them with the software. So, for example, they would type into their browser, yoursite.ca, something out on the internet. Another computer out on the internet will say, oh, if you're typing in this domain name, this is what this is called, a domain name, you want to go to this IP address. And so they'll route your request for this website through your internet service provider and to your router. And your router will say, oh, I know that this machine on my local network is serving up data for that website. Then your server will say, here's the file, and send it back to the person requesting it. So that's kind of what a web server and what the kind of the interplays of the network and where IP addresses and all that stuff come from. But you can do this with virtual machines. And the benefit there is that they're always connected to the internet. They have this IP address that's static. Sometimes when you get IP addresses for your internet service provider, they can change all the time, which makes it really hard to host websites yourself. Anyway, just wanted to give you an idea of what a web server is. It's a piece of it's a computer running a piece of software that will serve up web pages to people who are asking for them with their web browsers. Okay, so what do some of these websites look like that are being run on the Computer Canada Cloud in their virtual machines or virtual web servers? This is one that Claudio Borda has been running in his group at Dalhousie University. It displays information about Inuit group in in the north, and different geo information like locations of different different towns and locations and things like that on their site in a map. It has lots of interesting information there. This is the site, I believe, would be classified as a static website, but I haven't talked too much about the differences between static and dynamic. We'll talk about them more later, but I think this is a static website, but it has lots of functionality built into it. For example, these maps you can scroll in and out of, but that's mostly provided by a third party, Esri, which is the one who developed the software called ArcGIS, and they provide database services that this website interacts with. Okay, so this is another site that's worked on by a group at Cape Breton University called Diversity Cape Breton. It uses a tool called Islandora, which I believe was developed at UPDI, which is kind of a combination of other tools, like for example Drupal, which is a content management system, which we'll talk about a little bit later as well, and a repository called Fedora, which is just a way of storing files and organizing files and things like that. This is another website that had been hosted on Computer Canada hardware, Computer Canada Cloud. It's a map that has different points that were mentioned in classical literature, and they form sort of blocks that you can do through, like, for example, areas like the public gardens and stuff like that. So you can associate quotes from these books with physical landmarks that exist today still. Oh, and they use a tool called Mecca, which is another content management system. This is a website that was developed by a large international group from, and the main involvement locally is a professor at Dalhousie, Jennifer Bain, Barbara Swanson, and I don't know exactly the technologies they use. I was pretty hands off with most of this, so I don't know a lot about how it all works, but it does some really cool things where you can, but it interacts with a database of ancient chants and music, and actually does, like, I don't know if you've heard about optical character recognition for text. This has ways of doing it for music. And then so you can actually look at what the actual music is and stuff like that. I don't know a lot about reading music and whether that's changed over the years and how complicated this could be, but this is a pretty cool tool that they've set up in the cloud. Okay, and this is one that's a bit different. It doesn't actually present a website. What they do is they get data from drones that are flying over and taking pictures of the landscape, and what they want to do is identify landscapes that could have been anthropogenic. So in the past, humans have done some kind of activity there, agricultural or something, and it's affected the landscape. And I think they're looking at sort of things that happened quite a long time in the past, and how that shaped the landscape into the present day. And they use their cloud VMs to sort of collect the data in real time and process it, and give them results that they could act on in the field. Okay, so that's some examples of what people are doing in the cloud, but I want to sort of talk a little bit more about the technologies that they use for these websites. A lot of the sites that I talked about, like for example, Drupal, Mecca sites, things like that, those are what are called dynamic websites, or content management systems, they're often referred to as. These are usually written in a language called PHP, hypertext preprocessing. And what they do is they actually generate, so your web browser looks at HTML. and we'll display that as a website. And what PHP does is it will run a program or a script to generate that HTML file. It could be, for example, pulling data out of a database. It could be responding to input that the user has done on their end, like entering a name or clicking on a button or something like that. But the HTML doesn't actually exist anywhere. It's created by running this program, which is kind of an interesting thing. These programs that run, these hypertext preprocessor programs that run, they can write data to databases on your virtual machine. They can save files to your server and actually change your website. So as I mentioned, they often require databases. These databases are used to store login information about users and other bits of information you want to keep about users, like last time they logged on, for example. It also contains information about the pages that are on your website. So what the text is on a page, links that might be there, things like that. And other bookkeeping stuff that your content management system might need to do its job. There's a lot of examples of these, like for example, WordPress is really popular. Drupal I already mentioned, Joomla is another, Omeko is another site that we came across. MediaWiki is even one of these, right? It's another content management system built off using PHP and databases as well. So what are the capabilities of these sites? You can have custom content for any visitor who logs on. So for example, they can use a username and a password to log on. This means that you could have admin pages. So an administrator could log on and they're given special pages that let them manage the site, configure it. You could have people who log on and can get shopping carts to enter, add, and remove items to their shopping carts for later purchase. You can keep track of account balances and things like that if you've got a bank website or whatever. This allows you to change the database in response to user input, which I sort of already mentioned, by creating pages if you're editing and managing the site, placing orders if you're a store website, or paying for bills if you're running a bank or something, a bank website. So these kinds of websites allow you to do file uploads. In some cases, not all. Sometimes they'll disable those for security reasons, but in theory, the software is created such that you can do this. The same thing, for example, the site itself can be edited and modified directly through these websites. And these systems can be quite complex. These content management systems can be fairly complex. Lots of code, many different components and files and things involved here. So what are the implications of this? Well, security becomes very important. If you have a website that can modify itself or your virtual machine, you've got to be very careful about in what ways it can be modified. So security becomes really important. Any visitor to the site could potentially modify it in the virtual machine. So you have to have your software designed very carefully in such a way that they can't, or at least not in ways that you don't want them to. Logins to these sites need to be secured. One type of attack that's fairly common on popular websites, like for example WordPress, is a brute force attack. And it's a pretty simple, well, at the face of it, it's a pretty simple attack, but it can get more complicated. But what people do, well, actually people program computers to do this, they don't do it themselves, is just try different usernames and passwords over and over again. And these can be pretty complex. They can actually do this from multiple different computers together to try and guess passwords and usernames. And the reason you can do it from different computers is because if you detect that this is happening from a particular computer, you can block it. But if it's happening from lots of different computers, it's much harder to block. So these brute force attacks can get pretty sophisticated. So, for example, you need to worry about sensitive data if you're storing like credit card numbers or even the passwords that people use to log into these sites. A lot of times people reuse passwords, like the same password used for the banking they might use for your site, maybe. I mean, you can't be sure. People do like to use reused passwords. And if they break into your site, get their password, then maybe they could log into their bank account, the hacker. So it's very important to start thinking about security. It's important to keep your content management system up to date as people discover new vulnerabilities in these content management systems. And so you have to keep your content management system up to date as people fix these vulnerabilities. Plugins, so a lot of these content management systems have additional functionality you can get by installing other bits of software that run on your virtual machines. And so this, this extra bit of software could have a vulnerability in it, right? So you need to be careful about what plugins you choose. You need to make sure that you are getting it from a source you trust, a group that you trust. You want to make sure that that group didn't just write the software and walk away, that they're watching for vulnerabilities and fixing them and releasing security updates. And then that means that you probably want to also be updating your plugins about as regularly as your content management systems to avoid these kinds of exploits, at least the known ones. There could be ones that aren't known yet, but they haven't fixed it, that people are still trying to exploit. But you know, if you get the ones that are well known, you'll be a little bit safer. So what dynamic websites do a lot of work, right? You can be very flexible. You don't necessarily, you can modify the website right through the website, which is kind of nice. And one of the things that I thought of early on, when I set up my first web server, I thought to myself, I don't need to worry too much about security. I'm just a little guy. There's nothing to gain from hacking my site, right? And it's not a big deal. No one's going to want to hack me. Why would they want to hack you? Well, I learned that they don't care if you're big or small. They want to hack into you, your site, just so they have more computers under their control. They use these computers to attack other computers, other websites. So you do need to worry about security, unfortunately, even if you're a small little guy, if you're not a bank, which is really sucks, but it's the way things are. The first server I set up I looked in the logs and I could see repeated attempts to try and connect to it over and over again through this SSH tool that I was talking about. And I've seen on the Compute Canada cloud some successful SSH brute force attacks on people's VMs. So people have been hacked through these brute force attempts. Generally, you're safe against those, but if you do some things on the VM that make it vulnerable for these types of attacks, you can be compromised. I also helped to administer a Drupal website, and again, it also got hacked. I was able to rebuild it from backups that I've saved. But once the site was hacked, I had to sort of worry about, the database could have been compromised. So if I didn't rebuild the database from before the site was hacked, from a backup from before the site was hacked, it could have gotten infected by data that was in the database. So you have to be very careful when you're rebuilding after one of these once your VM gets compromised. And the reason it was hacked was because I wasn't quite quick enough updating to a newer version of Drupal. They found a vulnerability, fixed it, and it was being exploited. And within maybe a month or two of that release, we got hacked. So you have to be doing this on sort of a weekly to monthly kind of basis. Okay, so now that maybe I've scared you about dynamic websites, are there alternatives? And there is. There is an alternative to dynamic website. That's kind of the whole point of this talk, to some degree. Static websites. Now, they're not new, really. They've been around since the web started. First websites were just plain HTML. And the benefit of these plain websites is you can't modify them through the website itself. All the content is sort of it's already decided about what's going to be there when you make the website. So these static files are generated not by your web server, for example, with like the other content management systems. So when do these fit people's usage case? They fit when you want all of the visitors that come to the site to see the same content. So you don't have an administrator login where people can edit pages. You don't have shopping carts or account balances you want to display. You've got just a website you want to display to all users. So it could contain maps or menus that they navigate to different pages and stuff like that. But you can't customize the content for a particular person. This wouldn't work, for example, if you want to set up a site to manage like registration for conferences or something like that. As I mentioned, you can have dynamic elements like maps and menus and stuff like that using JavaScript. So traditionally, these kind of static websites were handcrafted by web developers, people who knew HTML and the different in JavaScript and these different kinds of tools to build websites. But more recently, there's these tools called static website generators, which kind of make static websites a little more like these dynamic websites in the sense that You don't have to know HTML and JavaScript and all of this other stuff, all these other web technologies to make a website. You can create your website content in a very simple format called Markdown, which allows you to do things like include links and images, and I think you can include videos and stuff like that too, and of course all your texts and those kinds of things. And there's themes that you can get to make your site look a certain way, which is very similar to what you do with these dynamic websites. They often have different themes you can choose from. And then you would edit your pages using some tools in the website itself. Markdown is, I'll show you a little bit of Markdown later, but in a little bit, just so you get a feel for what it looks like. Anyway, so you can choose these custom themes. If you know a little bit of HTML, CSS, or JavaScript, you don't even need to use JavaScript, but just HTML and cascading style sheets, you can build your own themes. Or you could get a web developer to build these for you if you need something that's customized, not off the shelf. There's a bunch of popular static website generators like Geroux and Hugo and things like that you can choose from. Okay, so I've got a confession. You may not have realized this, but these slide decks are actually created using a static website generator. The one I use was called Geroux. It's one I've become familiar with, and I like it quite a bit. So I had to create a few HTML templates, some cascading style sheets to position things and things like that. And one thing that after I did that bothered me was that to change slides, I actually had to click on down here at the bottom. There's a next and a previous. I'd actually take my mouse and click on those. So I wrote a little bit of JavaScript that lets me use the arrows on my keyboard, like a lot of other slideshow things let you do. And once I did all of that, I can create a slide using this kind of markdown here that I've shown you on the slide. So this is actually the markdown to create the slide here. So you tell what kind of page you're making, you give it a title, and this stuff can change a little bit depending on the theme you're using. And then, for example, to make the bullets, I just do a star. This is what a link looks like here. And then I can indent and do some more stars to do the second level. That's kind of what, what level you'll be editing and creating your files. If you're not worrying about creating a custom theme, you just want to use one that's already existing, you'll be working at sort of this level to use one of these static website generators. Once you've created your content, or created some of it anyway, and you want to see what it looks like through a web browser, you'd run a command on the command line. It'll generate that, and then you can go look at the site, either locally or through your virtual machine's public IP address. Okay, so just to give you we're running quite short on time here, but you can do quite a lot with these static websites. And here's a couple examples. I was originally thinking of clicking on them and showing you what it looked like. I think I might skip that just for time's sake. But the one on the left here actually has dynamic menus you can click on, things like that. This one has embedded videos. This one has animations on the web page where things slide in and out of view as you walk through it. So you can have some pretty dynamic and interesting websites. And by dynamic, I mean that change things, not necessarily customized content per user. Okay, static websites, they're simple. That's the thing that's really nice about them. You don't have all this hidden complexity that you get with the dynamic websites. This is this quote that I really like from Einstein: everything should be made as simple as possible, but no simpler, right? So you want to choose a tool that gets your job done, and you want to choose the simplest tool that gets your job done. If you don't need a dynamic website, don't use one. That's kind of what I would like to say. There may be cases where you need one, right? There are certain tasks that you need to do in your research that might just not fit for a static website. And that's okay. If you can't use a static website, you can't use a static website. But if you can, it'll save you a lot of headaches and work. If you are using a dynamic website, then I would suggest you have a bit of an idea of what your kind of the maintenance and security things you need to worry about are. Maybe have someone involved who has experience with those kinds of things. So static websites are really easy to back up. They're just a bunch of text files. You can save them to a folder on your desktop. You can put them under version control if you know what that is or like to use it. It saves changes from one version to another. Git is a popular version control software, and they offer cloud hosting, so you can actually put your version files up on their website. So that gives you an extra layer of safety, because it's saved on your laptop, it's saved on someone else's computer in the cloud, and on top of that, Git even actually also will do website hosting for you. So these slides that I'm showing you today in the presentation are actually running, they're coming from my virtual machine that I've got running on the previous cloud. But you can also view them on GitHub, just like I'm showing you today. So they offer, you can actually put your website on GitHub. It's not quite as fast. That's why, one of the reasons why I'm using the virtual machine. Some of the pictures take a little longer to load and stuff like that. So if you had a really heavy website, you might not want to put it on GitHub. It's easy to set up. There's no databases to worry about. Maintenance is much, if you go for older versions, it's not as big a deal because you don't have to worry about security vulnerabilities as much because you can't modify the site through the site. You don't have to, so SSL is what gives you the HTTPS, the secure HTTP connection. This is less of a worry, but I would say not zero. I've heard about some things recently that I wasn't originally aware of, that people can modify your HTML and transit between your website and somebody's browser, which is a little bit freaky. But if you have, if you're encrypting the data you're sending back and forth, you're a little more safe for that. So I would maybe even recommend SSL even for static websites, but it's not that hard to set up. Okay, so maintenance, security, and backups. Just some bullet points here to keep in mind when you're running your site. Make sure you can rebuild it. If you created a VM, you run some commands to create your VM and configure it, install websites and web services and stuff. Keep all those commands. Write every command you run down in a text file so you can rebuild it. It's really good to be able to rebuild your virtual machine for a variety of reasons. Any non-reproducible data, like your site content or images, that you back those up so you can rebuild it. Eventually, you're going to have to rebuild, no matter what, really. If your server becomes compromised, you'll have to rebuild. If you are running a version of your operating system that has become, that they're no longer releasing security updates for, you'll have to go to the next major version, which often will require a fresh rebuild. Sometimes you can do it in place, but not always. Keep your operating system updated. This is sometimes done in automated ways, but often will require restarts of your virtual machine every once in a while, so you still have to log in and do those. And if you have a dynamic site, you also have to keep your content management system, or like Drupal or Mecca, up to date, and all the plugins updated as well to feel safe. Okay, so where to go from here? I just put a whole bunch of information at you, which I'm assuming you won't digest immediately. But these slides are available, as I mentioned, on GitHub. There's the URL for them, and I believe we're going to send out information about that later. And you can also view all the source that I used to make these slides. If you wanted to see what Jekyll, what the HTML and stuff looked like for Jekyll, you can look at it on my GitHub repo. And in the fall, we're going to do sort of an end-to-end hands-on workshop where I talk to you about how to create a virtual machine, how to set up a web server, and an introduction to using tools like Jekyll to make your static websites. If you want to try things on your own, we do have a little bit of documentation about, for example, how to get a Compute Canada account. Once you have a Compute Canada cloud, you can request a cloud project. It's kind of a separate step. We do have some docs about using their virtual machines, setting up an Apache web server, which is what you would use to serve your website, your static website. And then you can look into documentation on Jekyll or another static website generator to get started. But if you would like to sort of go through this process with me and some others, we'll be looking at this in the fall this year. So that's the end of my rant or my spiel.